In section 3, we're going to talk about the last operations with rational expressions, and that's adding and subtracting. So there's going to be two different adding and subtracting types we look at. The first is when you have common denominators. So just to kind of refresh, if you have two fractions and you with common denominators like 2/3 and 7/3, if I want to add them, I just add the numerators. So 2 plus 7 is 9, and the denominator stays the same, 3, and then I simplify, and 9 divided by 3 is 3. And it works the exact same way for rational expressions. So if you have a over c plus b over c, the way you combine those is you just do a plus b and you keep the denominator the same. And similar to when we were multiplying, c cannot equal 0 because we can't divide by 0 with fractions. So in our first example, we have 3 over x plus x squared over x. So I can just combine my numerators, 3 plus x squared all over x. And we want to check to see if it simplifies in any way. And 3 plus x squared, there's no simplifying that, there's no factoring, so that's my final answer. Second example, we have x squared over x minus 3 minus 9 over x minus 3. So we'll have x squared minus 9 over x minus 3. Now this I can simplify because x squared minus 9 I can factor. It's a difference of squares. X plus 3, x minus 3, all over my denominator of x minus 3. If I look, I can cancel the x minus 3's. So I'm just left with x plus 3. Let's take a look at a little bit harder of examples. So we have x plus 3 over 12 minus 5x minus 17 over 12. So when I combine these like terms, I have to remember that I am subtracting the entirety of 5x minus 17 from x plus 3. So I want to distribute that negative into that entire second fraction. So it's going to become x plus 3 minus 5x plus 17 all over 12. So then x minus 5x is negative 4x. 3 plus 17 is 20. And then I still have my denominator of 12. So in my numerator, I'm going to have a GCF, negative 4x and 20. If my number in front of x is negative, I'm actually going to factor out a negative. That way I don't have to deal with a negative in front. So when I factor out negative 4, I get x, and then it actually becomes minus 5 all over 12. And now I want to simplify 4 and 12. So negative 4 and 12, both divisible by 4. So I get negative 1 and 3. So my final simplified answer is going to be negative, and then in parentheses, x minus 5 all over 3. So just like when we were multiplying and dividing, I am not going to distribute anything back into parentheses. We are going to leave it in factored form. Our next example, x squared over x squared minus 9 minus 6x minus 9 over x squared minus 9. So it's going to become x squared minus 6x plus 9, because I am going to distribute that negative to both terms, all over x squared minus 9. So I want to factor my numerator and denominator here. So in my numerator, I'm looking for the numbers that multiply to 9 and add to negative 6. And that's going to be negative 3 and negative 3. And in my denominator, x squared minus 9 is a difference of squares. So it factors as x plus 3, x minus 3. So there is one x minus 3 in the numerator and denominator that I can cancel. I can't cancel both of them because there are not two of them in the denominator, there's only one. So my final answer is going to be x minus 3 over x plus 3. second thing we're going to talk about is adding and subtracting rational expressions with unlike denominators. So when it comes to adding or subtracting two fractions that don't have the same denominator, we had to get the same denominator. So if I have 2/3 plus 7/6, I have to rewrite 2/3 as a fraction with a denominator of 6 because I can make a 3 a 6. To do that, I multiply the top and the bottom by 2. So then I end up with 4/6 plus 7/6. And once they have the same denominator, I add my numerator. So 4 plus 7 is 11, all over 6, and that's my final answer. There's also the type of problem where you can't multiply just one fraction, you have to multiply both. So I have 9/7 minus 10/8, and I can't make a 7 and 8. So what I have to do is I have to find the LCD, my least common denominator, which in this case happens to be 56. So I have to multiply 9/7 by 8 in the top and the bottom, and then 10/8 I have to multiply the top and the bottom by 7. So we're going to get 72 over 56 minus 70 over 56. And 72 minus 70 is 2. My denominator is still 56. And 2 over 56 can simplify because 56 is divisible by 2. And we end up with 1 over 28. So works the exact same way with rational expressions. If you don't have common denominators, you have to multiply one or both fractions by whatever is necessary to get them to be common denominators. So let's start with a couple examples where we have some monomials. So you have 2 over x squared y plus 5 over 3x cubed y. So when it comes to monomials, we're going to find our LCD. We want the denominators to be the same. So we want them to have the same numbers, the same exponents for variables, whatever those may be. So if I look, one of my denominators has a 3 and the other doesn't. So 3 has to be part of my LCD. When I'm looking at my variables, I have an x squared and an x cubed. So when it comes to the LCD, I always take the higher of the exponents. So I do need to have 3 x's. And then I have my y's. And there's only one of each. So my LCD has to be 3x cubed y. So now I'm going to multiply each fraction by whatever they're missing from the LCD. So x squared y is missing the 3 and an x. So whatever I multiply the denominator by, I have to multiply the numerator by. My second fraction is already the LCD, so I don't have to multiply it by anything. So 3x times 2 is 6x. I'm going to have over my 3x cubed y plus 5 over 3x cubed y. Now that I have common denominators, I can go ahead and combine them. I get 6x plus 5 all over 3x cubed y. And there's nothing else I can do to simplify that further, so that is my final answer. Our next example, we have 5a squared over 6b plus 9 over 14a squared b squared. So for my LCD, I can't make 6 14, so I need to figure out what number 6 and 14 both go into. So I'm going to start looking at some factors of 14 and multiples of 14 and see if any of them are also a multiple of 6. So 14 times 2 is 28. Unfortunately, 6 does not go into 28. 14 times 3 is 42, and 6 does go into 42. So my LCD is going to contain 42. If I look, my one denominator has a squared, and the other doesn't have any a's. So I do need to have a squared as part of my LCD. And I have a b and a b squared, and the higher exponent is b squared. So that has to be part of my LCD. So for my first fraction, 6b needs to become 42a squared b squared. So in order to make 6 42, I have to multiply it by 7. In order to get the a squared, I have to multiply by a. In order to get b squared, I need to multiply a b. So I need to multiply my numerator by that as well. For my second fraction, 14, in order for it to become 42, I multiply by 3, and it already has a squared b squared. So I just have to multiply the numerator by 3 as well. So 7 times 5 is going to be 35. A squared times a squared is a to the 4th, and then b all over 42 a squared b squared, and then plus 9 times 3 is 27 over 42 a squared b squared. So when I combine it to single fraction, I get 35 a to the 4th b plus 27 all over 42 a squared b squared. And again, cannot simplify that any further. That would be our final answer. So what happens if we don't have monomials? So very common for us that we're going to have polynomials or binomials or trinomials in our fractions that we're going to want to combine. So in our first example, we have 2 over x squared minus 49 plus 3x over 2x plus 14. Now my LCD is not going to be just, oh, whatever is, I got an x squared I need, I got a 2x and a 14. What I want to do is, if it's not a monomial in the denominator, I want to factor my denominators and look for factors that they have in common. So x squared minus 49 factors as x plus 7, x minus 7, and the 2x plus 14, I can factor out a GCF of 2, and then I have x plus 7 left in parentheses. So when I go to identify my LCD, one of my denominators has a GCF of 2, so that has to be part of my LCD. They both have x plus 7, so that's going to be part of my LCD. And then my other denominator has an x minus 7, so that also has to be part of my LCD. So any factors that appear in the denominator have to be part of the LCD. So for my first fraction, the only thing it's missing out of the LCD is 2. So we're going to be multiplying the numerator and denominator by 2. And for our second fraction, it's missing the x minus 7. So we're going to multiply the top and the bottom by x minus 7. So 2 times 2 is going to give us 4 over 2 and then x plus 7, x minus 7, plus, now the 3x times x minus 7, I'm going to distribute. So 3x times x is 3x squared. 3x times negative 7 is negative 21x over the 2x plus 7, x minus 7. So when I go ahead and combine like terms, I'm going to want to rewrite it in descending order just to make it easier. So I'm going to have 3x squared minus 21x plus 4, because there's no like terms here, all over 2x plus 7, x minus 7. Typically, I would now try to factor my numerator, but I'm going to go ahead and tell you right now it's not factorable. If I were to try to factor it, I'd be looking for the numbers that multiply to 12 and add to negative 21, which there aren't any that exist. So it's can't simplify any further, and this is our final answer. All right, our next example, we have x plus 10 over 3x minus 15 minus 3x plus 15 over 6x minus 30. So before I start identifying my LCD, I'm going to factor my denominators. So 3x minus 15 has a GCF of 3, so I'm going to factor that out, and I get x minus 5. 6x minus 30 has a GCF of 6, and that leaves me with x minus 5 in parentheses. So for my LCD, both of my denominators have GCFs. One of them is 3 and the other is 6. Now the nice thing is I can make a 3 a 6. So my LCD is going to contain 6. And then both of the denominators have x minus 5 as a factor. So that's also going to be part of my LCD. So my first fraction, in order to make a 3 a 6, I'm going to multiply it by 2. So I'm going to multiply the top and the bottom by 2. And my second fraction, already has my LCD as its denominator, so I don't have to multiply by anything. So I'm going to distribute that 2 to my entire numerator, so we get 2x plus 10 over the 3 times x minus 5 minus 3x plus 15 over 6 times x minus 5. So remember, that negative applies to my entire numerator of 3x plus 15. So we're going to do 2x minus 3x, which is negative x, and then we're going to do 10 minus 15, which is negative 5. Then we have 3 parentheses x minus 5. And then this is actually as simplified as it's going to get. I could technically factor a GCF of negative 1 from my numerator. So it becomes negative 1 parentheses x plus 5. But my denominator is still 3 parentheses. Sorry, not 3, 6. 6 parentheses x minus 5. And there's nothing to cancel or simplify there. So this is going to be our final answer. All right, last 2 examples. So we have a minus 5 over a squared plus 4a plus 3 plus a minus 2 over a squared minus 1. So my first denominator is going to factor as a plus 3, a plus 1. My second denominator factors as a plus 1, a minus 1. So for my LCD, there's no GCFs. So I start with the factor they both have, a plus 1. And then my first denominator has an a plus 3, and my second denominator also has a minus 1. So all 3 of those are part of my LCD. So my first fraction is missing the a minus 1, so I'm going to multiply the top and the bottom by a minus 1. The second fraction is missing a plus 3, so I'm going to multiply the top and the bottom by a plus 3. So this is a little bit more difficult than the last couple examples, because instead of having a single term to just distribute into the parentheses, I now have binomials. So I have to do a minus 5 times a minus 1 all over a plus 1, a plus 3, a minus 1, plus, and then I have to do a minus 2 times a plus 3 all over a plus 1, a plus 3, a minus 1. So I have to use the distributive property in my numerators. So a times a is a squared. A times negative 1 is negative a. Negative 5 times a is negative 5a. And then negative 5 times negative 1 is positive 5. Still all over a plus 1, a plus 3, a minus 1. And plus, and then for our second fraction, a times a is a squared, a times 3 is 3a, negative 2 times a is negative 2a, and then negative 2 times 3 is negative 6. And my denominator is still a plus 1, a plus 3, a minus 1. Now I'm going to combine like terms. I could combine like terms in each numerator and then combine like terms all together, but that's an extra step. So I have a squared plus a squared, which is going to be 2a squared. Negative a minus 5a is going to become negative 6a. And 3a minus a is a. So I have negative 6a plus a. So it gives me minus 5a. And then 5 minus 6, which is negative 1. All over a plus 1, a plus 3, a minus 1. And again, I would check to see if it factors, but this doesn't factor, so this would be my final answer. And again, leave the denominator completely in factored form. Last example, n plus 1 over n plus 2 minus n minus 1, n minus 3 over n minus 1. The nice thing is my denominators are already factored. can't do anything to them. So my LCD, they don't have anything in common. So my LCD is just going to be what appears in my denominators, n plus 2 and n minus 1. So the first fraction, we have to multiply the top and the bottom by n minus 1. And in our second fraction, we have to multiply the top and the bottom by n plus 2. So we're going to have n minus 1 times n plus 1 over n plus 2, n minus 1, minus n minus 3 times n plus 2 over n plus 2 times n minus 1. So just like our previous example, I have to use the distributive property. So n times n is n squared, n times 1 is n, negative 1 times n is negative n, negative 1 times 1 is negative 1, all over n plus 2, n minus 1, then minus n times n is n squared, n times 2 is 2n, negative 3 times n is negative 3n, then negative 3 times 2 is negative 6, all over n plus 2, n minus 1. Now this one, I have to remember that we're subtracting. So here's the nice thing. In my first fraction, the plus n and the minus n are going to cancel. So I'm just left with n squared minus 1 over n plus 2 times n minus 1. And then minus, I'm going to have n squared minus n minus 6 over n plus 2 times n minus 1. So when I combine like terms here, I have n squared minus n squared, so they're going to cancel. There's no more n's from my first fraction, so it doesn't stay negative n because you have to remember you have this negative that is distributing. So the minus n is actually going to become positive n. And then you have negative 1 minus negative 6, which is going to become addition. So it's negative 1 plus 6, which is going to become n plus 5 over n plus 2 times n minus 1, which is our final answer. So let me know if you have any questions about adding and subtracting rational expressions, whether that's adding and subtracting with common denominators or adding and subtracting with uncommon denominators.